kids, the central question we want to ask, how about I want you to read this here, I guess. Maybe that's the thing I want you to do. Read the first sentence. Not the whole question, but the first sentence. Who wants that one?
What are some common characteristics of the graphs of cubic and quartic polynomial functions?
Okay, so right here, 2 words to underline, cubic and quartic. Cubic meaning what power, kids? Third. Anybody know what quartic means?
Fourth power.
Maybe fourth power, okay? Quartic. It's like quarter. How many quarters in a dollar?
4.
How many quarters in a football game? Quartic, meaning fourth. So we're instead of looking at stuff just to the second power, we're going to start looking at things to the third and the fourth power, okay? Now, this is where things can kind of get intimidating if you first look at this. It says a polynomial function is of the form, and here's how you read this. F of x is equal to a sub n x to the n power plus a to the sub n minus 1, x to the n minus 1 plus dot, dot, dot. This goes on forever. You just keep subtracting from the power all the time. So as an example for a polynomial, what's a polynomial function? You might see something like this. I'm going to just go right down here. This is what a polynomial function is here in green. It says a of n cannot equal what? 0. And it says it's cubic when n is equal to what value, kids? 3, and quartic when n is equal to what?
4.
Okay. Right here I wrote a or n. They're just simply what? Some number. And specifically they are some, well, I should back up on that. They're some number. Just leave it at that, okay? Polynomial function. Here you go. Here's an example. Two x to the 99th power plus 3x squared. You guys want to start working with functions to the 99th power? I don't. If I ever had to, I'd be DUN done. Okay? 99 powers of math on the page. 99 powers of, okay, never mind.
Math, take one down, pass it around.
98 powers of math on the page. Ah, I love it.
We should dedicate a whole class just to singing.
Singing that song? Oh, I'd have to come up with a better one, okay? I'd have to go find Barthelmess and he'd help me make a rap. All right? So, polynomial function, simply put, all it is it's a function of the form a of n, or a sub n, x to the n plus a n minus 1, x n minus 1. All these a's and n's they're just some, what? Don't let the form fool you, okay? Up here, a polynomial is just a bunch of monomials or a sum of monomials. Let's make sure we understand the difference here. Okay, I'm going to jump down to the monomial part of my definitions here. A monomial is a number or the product of a number and one or more variables with whole number exponents. This is huge right here. Have to have whole number exponents. Whole numbers like 6, 12, 14. Not numbers like 1.6 or square root of 7 or negative 4. Whole numbers. Start at 0 and start counting by ones. All right? Here's an example of a monomial. 3x squared y. Okay? Is that a combination of numbers and variables right there? Okay. Now how's a monomial different from a polynomial? Well, a monomial is just simply one expression. Up here at the very top, I wrote down that polynomials are a monomial or a what? So here's an example of a polynomial. Something like 3x squared y plus 2x minus 7. That's an example of a polynomial. How many terms are there between plus and minus signs here? Well, the first one before the plus is 3x squared y. That's one monomial. 2x is another monomial, and 7 is another monomial. So how many monomials make up this polynomial?
3.
3 of them. Okay? Here's a quick question for you. Which one's the monomial? First one or second one? Second one is because, is there any addition or subtraction going on here?
No.
Where's the addition or subtraction going on?
Top.
The top one. Okay? This is the polynomial. This is the monomial. You have to have what kinds of signs to have a polynomial? plus or a minus somewhere. Okay? All right, so understand the difference there. Let's go back to our terms. This end behavior thing is going to become something that's really important today. Okay? Okay, end behavior. How about a volunteer to read what end behavior is? That's going to be a big concept we focus on today. Anybody want?
The behavior of the graph as x approaches positive infinity or negative infinity.
Okay, so it's basically saying what happens to your y values when x get really, really large. In other words, if I wanted to go to a place like, say, I don't know, 1 million, like say you go over on the x-axis 1 million places, you want to say, where's the y value end up? What's happening to the y value? Or what characteristics does y have? Okay? Or if you go really far to the left, where's your y value going? Okay, and we're going to look at things like that. So, guys, end behavior is kind of like saying this. It's kind of like saying what happens to your y values as x, and we say approaches either positive or negative infinity. In other words, as x gets really, really big, what happens to your y values? That's what that's saying right there. So end behavior is going to be something we focus on. And I think you're going to see some easy characteristics on this as we go ahead and look at some examples. I think you'll understand that end behavior is not as hard as it's cut out to be, but I want to make kind of a cheat sheet for this to help you with this, all right?
Wait, what is that thing after the plus?
So this is like a sideways 8. It's a symbol for infinity.
Okay,
Okay?
I couldn't tell.
And I'm not very artistic with that, but this is what it should look like. Okay? Infinity. Got it?
Yes.
Okay. And you were talking right here, right? What happens as x approaches plus or minus infinity right here? Okay. Great question. And it's kind of listed right in here for you. Plus infinity and negative infinity, okay?
Got it.
Okay. All right. Linear functions, we know what they are. We are very used to the idea that slope-intercept form exists as y is equal to mx plus b. Kids, this is function form for any linear polynomial function. Okay? Instead of being an mx plus b form, what do they replace the m with? A1. Okay? They like their steak. Oh, come on, that was good. What do they replace b with?
I like steak, but I don't like A1s.
Neither do I.
A sub 0.
A sub 0. Okay? So understand that when you see this form right here, it's nothing different. They just use different notation to give you the same expression. Why they do that? I don't know. Makes you think, why do we have to have so many forms? So an example of a linear function might be f of x equals 6x minus 7. And if I had to say, what's your a1 value, you would say what?
6.
And if I had to say, what's a sub 0?
7.
A sub 0 means what's the constant value? Where are you starting? A sub 0 means what's the initial value? Okay? And initial value is like a y-intercept. So negative 7 would be a sub 0. And then you've seen the same thing with quadratic forms right here. This is quadratic form. You know y equals ax squared plus bx, plus c. But in function notation, they write it differently. They write it down as f of x equals a sub 2x squared plus a sub 1x plus a sub 0. Okay? So this a2 is really like what in the original one, kids? A1 is like,
B.
and then a sub 0 is like your constant or your y-intercept. So an example, f of x is going to equal, I don't know, give me a quadratic in standard form, anybody.
4x squared plus 3x plus 6.
Woo! What's your a2 value up there? 4. What's your a1 value?
3.
What's your initial value for a sub 0?
6.
Okay. Page 2. Anybody done with page 1? Anybody need more time? Page 2?
Yeah.
Who am I waiting for?
We need to go down.
Okay.
Plus minus 2.
Haley, I need you to teach us this lesson. I'm on the injured list. Can you do it for me? No? Okay. I'll try to suffer through. How's that sound? Okay. Guys, this is an important one. All right? Identifying polynomial functions. Okay, first of all, we're going to talk about what a polynomial function is. Again, I told you the exponents had to be whole numbers, meaning 0, 1, 2, 3, 4. I want you to think right now, you're going to get asked, is this a polynomial function? All right? The thing you want to understand about polynomial functions, they only exist if your exponents are a positive number that's whole or 0. Okay? You can't have negatives and you can't have decimals. So, right here, we'll do A together and then you'll have to try B, C, and D on your own. It says decide first of all whether the function is a polynomial or not. So if we're deciding if something's a polynomial, your job is to look at exponents and ask yourself, are my exponents whole numbers? So in A, where f of x equals negative 4x to the 5th plus 7x squared minus 2, what are your exponents up there? 5 and 2. Are they whole numbers?
Yes.
So is this a polynomial function or not? It is. This is a polynomial function. I'm going to write yes. Polynomial function because exponents are whole numbers. Okay, that's the first part of it. Then it says write this thing in standard form. Oh my gosh, are you kidding me? Standard form exists with polynomial functions too? Well, guys, take a look up here at this general form of a quadratic. What's the highest power in this quadratic? 2. Then it goes down to 1. And then there's 0 exponent over here, right? You always write stuff in standard form in descending order of exponents. So what's the highest exponential value up there? What's the next highest? What's the next highest? That constant's a 0, okay? Do I need to change the order on this, or is this good enough to go? It's already in standard form because your highest power is 5 and you just bring your powers down. So it's already in standard form. Is it okay if I abbreviate already in SF, kids? Is that okay? Okay. Next question you're going to ask is state its degree. The degree is based upon the highest exponent. So what is the highest exponent?
5.
We say this is a 5th degree function. The degree of this function is 5. Okay, it's degree 5. It's a degree 5 function. Why not degree 2, kids? Because 5 is bigger than 2. Okay? Next one they're going to say is, hey, by the way, what type of function is this? It is polynomial. When you get asked the type, your only options are this. It's either odd or even. And it's going to depend upon the degree of your function. So what degree did I have up here, kids? 5. So is 5 odd or even? It's odd. And I'll show you what they're talking about more when we talk about odd and even functions. But the type here is going to be odd. And then the last thing they're going to ask is, oh, by the way, what's the leading coefficient here? Well, the leading coefficient is going to be the coefficient of your degree. And if you're degree 5, what number is sitting out in front of x to the 5th right now? Negative 4 is your leading coefficient. Negative 4 is kind of like the leadoff hitter in baseball. It's starting this right here. Okay? Leading coefficient is negative 4. Okay? So what I'd like you guys to do here quickly is this. B, C, and D. Determine if, first of all, if it's a polynomial function. If it's not a polynomial function, can you answer those questions? No. Okay? So if it is a polynomial function, I want you to answer those questions up there. Standard form, degree, type, and then what the leading coefficient is. Take about 2 minutes here. Try to go through those. Talk with your table partner. See what you come up with, and then we'll come to a consensus here, all right? What's that, bud? Were you yelling at me?
Oh no, I wasn't going.
Do you need another one?
No,
Are you sure?
no, it still goes up. I just kind of know. This thing is just, it has no structure now.
All right, guys, let's talk first one here. First of all, is the first one part B. Is that a polynomial function?
Yes.
It is. Okay, what defines it or what makes this a polynomial function? Whole number exponents, 4 and 2. Okay, we're good there. So yes, this is polynomial. What's standard form for this? And by the way, I forgot to tell you, this is the same as square root of 3 here, okay? Square root of 3 times x to the 4th. So what's your highest power, kids? Square root of 3 times x to the 4th. So the highest power would be 4, right? So I have to write this as square root of 3 times x to the 4th for standard form. What's next? Okay, so plus a half x squared plus 19. That would be your standard form right there. Okay. So what degree is this? Okay, degree is 4. Hey, if the degree is 4, is this even or odd? What's your leading coefficient then? Leading coefficient would be the square root of 3, right out in front here. Okay, very good. How many had all that for B? Do we understand why it's a polynomial function, first of all? Because all of the exponents are positive.
Whole numbers.
Okay. Why did I change the order to put it in standard form?
So that the exponents went from highest to lowest.
So the power 4 had to be listed first, then the next highest was 2, and then your constant of 19 on the end. Okay, do we understand degree 4, kids? Do we understand why it's an even function? Okay, and then lastly, your leading coefficient, you understand root 3 there? Okay. Part C. Is h of x a function that's a polynomial function?
9
What's the problem?
is a negative.
Okay, so can I answer any of the questions if it's not a polynomial function? Okay, so I'm going to say no, this is not a polynomial function because you have what kind of an exponent? Negative exponent. Okay, well, how about your last one? Oh, sorry, Sam, go ahead.
For B, where did you get the degree from?
The degree is from the highest power. So what's the highest power up here?
Oh, 4.
Fourth power. You okay with that, bud? Degree is always, just think temperature. What's the highest temperature, okay? It's like the highest power. All right? How about the last one? Polynomial function, yes or no? In standard form, or do we need to rearrange it? It's already in standard form. What's the degree?
2.
So what family would that be from, by the way? It's going to be even. That's the type. What's the leading coefficient? Be careful.
1.
It's really 1x squared, right? By the way, what family of functions is this? This polynomial is a what? It's quadratic. Okay, leading coefficient 1. Guys, a lot of vocab, a lot of taking terms and applying it to polynomial functions. Do you understand those 5 things? First of all, is it a polynomial function? Are you okay with that? You understand what standard form is? Understand how to find degree? Understand to determine odd or even? And then do you know what leading coefficient is? Okay. Those are 5 important things that we need to understand so that we can be successful with the rest of this section. Okay? Anybody need more time with A, B, C, or D? Anyone have questions about A, B, C, or D? Gnarly. Example number 2. How many of you guys have a calculator that you can type in the whole problem and it just spits out an answer? Like you can put parentheses and stuff in your calculator. Okay, that's important. All right. Today you're going to be asked to evaluate stuff, and I don't doubt that you know how to do this already, but I want you to be very careful, and I want you to hear this. Okay. from now on, when you substitute any value in for a variable, I always, 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 always want you to put parentheses around anything you sub in there, okay? So, for example 2 right here, to evaluate this polynomial, it says, hey, by the way, evaluate f of x equal negative 2x to the, what? Plus 6x to the minus 3x plus 11. Before I go any further, is this polynomial?
Yes.
Yeah. What degree?
4.
Leading coefficient? Odd or even? Is it already in standard form? Okay, let's roll. To evaluate when x equals 4, we're really saying, hey, what's f of 4 right here? Basically, it's saying is anywhere where you have an x up here in your polynomial function, what are you plugging in? I want you to type stuff in exactly as I write it up here. Negative 2, what's taking the place of x?
4.
But I better put what around the 4? Parentheses 4 to what power, kiddos? Okay, plus 6 times.
Parentheses 4.
And you're typing, I'm writing exactly as you're typing, okay? Minus 3 times what, kids? I want to make sure we all get the same value for evaluating functions. So you tell me what you guys come up with when you do the finger strokes there with your calculator. Let's make sure we all agree. How much?
Negative 129.
Sam's getting negative 129. Emma, what do you have?
Negative 1.
Negative 129. How many are coming up negative 129 here right now? Is there anybody that's not getting negative 129 when they enter that mess? If I ask you to evaluate stuff, can you do it? Just keep in mind when you're using your calculator, always, always, always put what around your substitution? Parentheses, okay? Negative 129 is the right answer, okay? All right, kids. Negative 129. I'm going to blow this chart up here in a little bit, okay? And we're going to make some great notes on this, but I'm going to tell you right now, the chart we're about to look at is your lifeline for this section, okay? This core concept is going to be about end behavior today, okay? It's going to be about end behavior. All right? Where are my Cyclone fans at? Kind of like the Cyclones beat the number 6 team in the nation, and the fans' end behavior was, what'd they do? Storm the field. That was their end behavior. Right? How many watched that game? Anybody watch this? Okay. I didn't care for their uniforms.
Neither did I. I
Ugh.
didn't even recognize them.
I turned it on, I was like,
I know.
man.
I like looked.
I had them flip-flopped. I was like, why are Iowa State's
I had to take a
uniforms
double
all
look.
white? And then I
I
agree.
was like, this really is Iowa State, right?
Yeah.
I clicked on it.
Okay, important section here. I'm going to jump into Desmos. You stay with me quickly, okay? You guys ready?
Who's popular?
I'm popular. Okay, kids, right up here. I've put a function up here. What's the leading coefficient on this function?
1.
1. What power is this, or what degree is this? Okay, we're going to talk a lot about cubic and quartic functions in this chapter. All right, the first thing I'm going to start looking at is cubic functions. The reason this is cubic is because it's of degree 3. Okay, you're going to have this written in standard form, but I'm going to tell you right now. We're going to make a cheat sheet up for being successful in here with basically all cubic and all quartic functions. If you notice right here, kids, is the leading coefficient positive or negative here? Positive. Okay, here's what I want you to do. In that core concept area, here's what I want you to write. We're going to have 4 different types of functions that we're going to look at. So let me blow this up here. This top left one, let's look at this right here. We're going to call this an example where we're looking at cubic functions where the leading coefficient, I abbreviate LC. If I put LC up there, do you understand that means leading coefficient? We're going to look at cubic functions where the leading coefficient is a positive value. Okay? So here's what you're going to have happen. These graphs that you get, I'm going to put two coordinate planes up here. Okay? Cubic functions with leading coefficients that are positive will take on one of two shapes. It might look like, I don't know, I'll do my best to draw this. It might look like this, like we saw. It might come up, make a bump, come back down to a valley and take off this way. Okay? Or instead of having bumps, it might come from the bottom, work its way up, flatten out, and then take off like this again. But in either case, right here, kids, let's talk about the end behaviors. Over here on the left, is this graph moving down or up? On the left, is this graph moving down or up? Down. So the further I go left, the more downward this goes. Isn't that the same over here? The more I go left, the further down that graph goes, right? Okay. End behavior over here on the right. As I move right, where's this graph going in each case? Up. Okay. Here's what you're going to get asked about in terms of end behavior. Okay. They're going to ask you questions like this. They're going to say, what's happening to your y values as x approaches, what's this stand for again? And then as x approaches, we're also going to look, instead of going to positive infinity, we're going to look at going to negative infinity. All right? We're going to look at things as we go to infinity and beyond. Okay? We're going to go to infinity and maybe even beyond that. All right? Okay?
Oh my gosh.
What, Piper?
You have that?
He's cool.
I have the
Get
whole
that in.
collection.
But his button doesn't work anymore. And I'm sad.
Not the real ones, but like I have all the.
We have a Rex at home. You know, Rex the dinosaur.
We have the whole.
My dog hates that thing. What? We have him too.
Your dog hates the dinosaur?
When you squeeze him, he makes like that
Oh.
sound, and the dog just starts barking and going nuts. It's hilarious.
Don't you have like a little
I was confused.
Yeah, Milo. He's a little white terrier. Okay, here's what this is talking about, kids. Think about it this way. We're saying as x goes where first, kids?
positive?
So basically, is that moving right or left on the graph, kids? As I move right on any cubic function where the leading coefficient is positive, does my graph move upwards or downwards? Moves upwards. So I would say as x approaches infinity, in other words, going to the right positively, my y values are also increasing. So y is going to tend to approach positive infinity also. Okay? The bigger my numbers get to the right, what's going to be true about your y values, kids? So if I'm here, the more I go to the right, what's happening? This, yeah. Okay, and then same thing here. How about as x goes to negative infinity? Start at the origin, start moving left. Where do your values start ending up at? Well, they just keep, the further left I keep going, the further, yeah, further down they go. So as x approaches negative infinity, what's that mean about your y values then for any? Exactly. Okay. Now keep in mind, what type of function are we talking about here? What power? Cubic function. Is a cubic function odd or even?
Odd.
It's odd. What do you notice about the end behaviors for your y values? Are they the same sign or opposite signs? Keep that in mind. Odd functions will have opposite end behaviors. So if it's positive infinity over here on the right, then on the left it'll be negative infinity. Or vice versa. If it's positive infinity over here, it's going to be what over here? All right, so let's look at this. Guys, if this is an example of cubic functions, where your leading coefficient is what type of value? Positive. Let's say, what happens if I would change this leading coefficient to a negative? I'm just going to throw a negative sign in front. Looks like my, looks like my graph comes down. Let's check it out. Sketch a graph. This is what a cubic function. Oh, I screwed up. I need to write in there first. This box right here, we're looking at cubic functions where the leading coefficient is what, kids? Leading coefficient would be negative. Options for graphs. Here they are. Start out big like this, maybe weave around and head back down like that. Or they might start out like this, flatten out, and take off that way again. Okay? These are just general graphs. They're not exact graphs, they're just general shapes of cubic functions. Hey, I have a question. What do you think is going to be true about the end behaviors of leading coefficients that are positive compared to leading coefficients that are negative here? Let's check it out. As x approaches positive infinity over here, so I'm going positively, I'm going to the right. Where's my graph moving? Down or up? The more I go right on this, is this going down or up?
Down.
So I would say y approaches what then, kids? Is that the same as what we had over here, or just the exact opposite? Just the exact opposite. So what's the last statement then going to be here? As x approaches negative infinity with a cubic function where the leading coefficient is negative, where are your y values headed to? Yep. So as I go, basically this is saying go left forever on this graph. Okay, I'm going to go left forever. As I keep moving left on this graph, I'm also moving what other direction? As I continue to move left forever, I keep moving on up to what? In terms of y? Positive infinity, yep. Now I'm not going to put the graphs of the cortex up there. I'm just going to give you the general shape. And we're going to talk about the even and the odd comparison. But guys, your end behavior are your y values right here. On an odd function, are your end behaviors the same or are they opposite of each other? On the ends, they are opposite. Again, end behavior over here. Are the end behaviors the same or are they opposite? Let me get you a general graph for, well, we're going to look at quartic functions now. Quartic meaning what power, kids?
4.
So I'll look at a quartic function where the leading coefficient is a positive here, kids. Okay? General shapes, 2 general shapes that come up. Any Chicago Cub fans in here? Cub fans love quartic functions because they kind of graph out like this. Or sometimes they might come down and one of these might flatten out. It might come down here like so, flatten out, and then take off that way and go this way. Kids, I'm going to look back at my cubic functions. One arrow was always moving what direction? Down. And the other arrow was always moving up. What's true about my end behaviors in terms of arrows here? Are they both moving up, one moving down? They're going the same. Now, quartic function, that type, is that odd or even? End behaviors of even functions are going to tend to be the same. So if you have an odd function, end behavior will be opposites. Even function, end behavior is going to be the same. So when you have a quartic function here, kids, when you have a quartic function, let's talk about our end behaviors as x approaches positive infinity and as x approaches negative infinity. Help me. Where are the y values going? So as I move all the way to the right, I continue going what? Up. So y is going to approach positive infinity. How about as I continue to move left on the graph? Where do I finally end up? Going towards where? Positive infinity again. What do you notice about the end behaviors with respect to y here? Are they the same or are they the opposite? Okay. Well, if quartic function's general shape is like a W or something like this, What's a quartic function with a negative leading coefficient going to look like?
Going down.
Yeah, so a W might look like a what, kids?
M.
So your functions for a leading coefficient of a quartic function, and I forgot to write that, I'll do that right now. We're looking at quartic functions here, where the leading coefficient is negative. They might look like an M. Whee! Or they might look like this. They might come up, flatten out, take back off, and then head down like so. In either case, what's the end behavior? As x approaches both positive and negative infinity. What's the end behavior when the leading coefficient is negative now, kids?
Down.
So is it approaching positive infinity or negative infinity on both ends?
Negative.
So here's what we would say here. As x approaches positive infinity, meaning you keep moving further and further right. You keep moving further and further right. Where does the end up at? Just keeps going down. Y is going to end up at negative forever. Okay? Bless you. How about as x goes to negative infinity?
Y goes to negative.
Yep, the further left I move, eventually over here to the end, it just keeps going where?
Down.
Downward. Y is going to approach negative infinity. What do you notice about the end behaviors for y on even functions? Are they the same or are they opposite? They are the same. Okay? Now guys, I want you to flip to your notes here to example 3. I'm going to leave this chart up here. Okay? Well, flip to your notes in example 3. Okay? Example 3. Somebody want to read that for me? And we'll answer this tomorrow. We'll write it down tomorrow. But I just want to talk about it before we leave, because it all ties in right here. What's example 3 say? Somebody read that for me.
Describe the end behavior of the graph f of x equals negative 0.3x cubed plus 1.7x squared minus 4x plus 6.
Okay, so is this a cubic function or quartic function, kids? It's cubic, right? Third power, degree 3. What's the leading coefficient on this? Positive or what?
Negative.
Negative. So we have a cubic function where the leading coefficient is negative. So when we ask about end behaviors, we're going to say, well, if this is the function I have, we're going to say as x approaches infinity, y is going where, kids?
Negative.
And as x approaches negative infinity, in other words, going left, what's y going to approach? That's what you're going to say. That's when that chart's going to come in handy when you start doing it. Kids, I've sent out the online book page already. Actually, it's not due until Thursday, but if you want to get a good head start on it, I think we've got a lot underneath. We've got a lot to finish up tomorrow, too. So make sure you bring your notes with you. Don't forget, when's the deadline on the test for corrections?
22nd.
22, okay? 22nd of this month.